Hello everyone, Miss James here. I'm going to do this video to just walk you through how to write a conclusion. I'm going to have a sample screencast conclusion and also a sample written conclusion on the Moodle for the same lab data just so that you can see the application. So let's get started. In this lab, I'm analyzing how does the height of the image, how is the height of the image in a pinhole camera affected by the object distance? So the first thing you have to do is state that question. How does object distance affect image height when using a pinhole camera? And then because this isn't a mystery novel and we want to get the answer out right away, as is the tradition in science, we state what the answer is. We found that as the object distance increased, the image height decreased. And in fact, we found that we could use the following formula to predict the image height, that the image height equals Ho die over Do. We want to make sure that somewhere, either in the written or in the screencast, we show the data tables and the graphs. And then we want to analyze those data tables and graphs to help support what we said was the result. So I want you to really, in terms of using the data table, quote specific numbers from the data table. And then connect those numbers back to the result. So for example, when our object distance went from 3 centimeters and increased to 12 centimeters, the image height decreased. It started at 10.2 centimeters and went all the way down to 2.4 centimeters. That proves, or that is consistent with, as object distance increases, image height decreases. Then you can go to the graph. Let's look at the graph. In this graph, we've graphed object distance on the x-axis and image height on the y. And the fact that the graph slopes down also further backs up our claim that as the object distance increases, the image height decreases. The next section is advanced analysis. In advanced analysis, we want to go back up here and look at percent difference numbers. So when the percent differences are comparing the calculated image height to the measured image height, and we get very low numbers. So we get as low as 2% off and as high as 5% off. And we got that formula by analyzing the graph. When we look at the equation of the graph, we get high as 31 over DO. What could that 31 be? Well, when we analyze ray diagrams, we see that it's likely Ho times Di. Now, Ho was 2.5 and Di was 12. And 2.5 times 12 is awfully close to 31. So things like talking about things of that nature is what I'm expecting. The next section discusses why the results make sense. And you'll notice in the grading sheet that that's worth twice what any other section is worth. Why? Because this is where all the physics is. Why should image height decrease as object distance increases? Well, one of the best ways to do this is to draw two diagrams. One with the same HO and the same DI, but different object distances. And you'll see that when the object is far away, the angles on the triangles, on your similar triangles, are much smaller. This is easier to illustrate when you actually have a diagram, particularly in a screencast when you can use your cursor to point out these differences. Finally, we want to talk about the sources of error. This is not, we may have calculated wrong. This is not anything that maybe we didn't understand the lab. That's not scientific error. Scientific error are what limits the data from being accurate. So measurement error is a scientific error. We had to measure object distance, image height, and image distance, um, and object height. So all of those require measurements. And then, how good was our placement? Did we place them at the right DOs and DIs? Um, could the screen have moved a little bit during our experiment? All of those things are potential scientific errors. And the last part is future research. So this gives you practice in asking good questions. So I want a new scientific question. So that means it has to either have a new IV or DV, but still be related to the lab that we did. So instead of varying the object distance, maybe I could vary the object height, or maybe I could vary the image distance. A good hint is to look at those things that you're holding constant and maybe try to vary one of those. I hope this helps you. I hope you feel like you can take this um, screencast and apply it to any lab that you have. Good luck. Bye.